Chapter 12, chi-square and non-parametric tests. Previously in Chapter 9, we talked about one sample testing. In Chapter 10, we talked about two samples testings. In Chapter 11, we talked about two or more sample numerical variables. And now in Chapter 12, we talk about two or more samples, but now we're dealing with categorical variables. And the testing that we're going to use is chi-square testing. And for chi-square testing, what we're testing is for h null, we have pi1 equals to pi2 equals to all the way equals to pi c. And that's the h null. For h1, we have not all the pi, not all the proportion are equal. And to calculate the chi-square statistics, this is the formula that we're going to use. We're going to go through that in the example in a moment. And basically the FO represent your frequency observed, and the FE represent your expected frequency. And then for chi-square statistics for 2 times 2k's, we have a degree of freedom of 1. And for the decision rule, it's the same as before. As long as our statistics is greater than critical, then we can reject h null. Otherwise, we do not reject h null. And for chi-square distributions, and in terms of distribution for chi-square, what we have is similar to the F distribution, where we have the right tail. Right tail means that we have right skewed. And when we're calculating the chi-square statistics, what we're interested in is the right side, just like the F distributions. So the formula that we're going to use to calculate the p-value for chi-square is chi-square.dis.rt, and for critical value is chi-square.inv.rt. Those are the two formulas that we're going to use. Example 1, suppose we examine a sample of 300 students. Are the proportion of left-handed children equal for both male and female at the 5% significance level? So when we're dealing with chi-square testings, what we have is categorical variables. And what we see in the table here is that in the row, we have male and female, so gender. This is categorical variables. In the column, we have hand preference. So we have left hand, right hand. And these are categorical variables. So we have two categorical variables, gender and hand preference. And in the cell, we have the count. So these are the actual observations. And for part A, what we have is state the null hypothesis and the alternative hypothesis. So for the hypothesis, we look at what we are given in the lecture notes. So for chi-square testings, what we're saying is that for h null, we're saying that the proportions are the same for all of them. So pi1 equals to pi2 all the way to pi c. And then for h1, we're saying that not all the proportions are the same. Not all the proportions are equal. And this is what we're testing in this example as well. We're trying to prove that h1, we're trying to prove that not all the proportions are equal. And before we prove that, we have to assume that h null is true, which is that pi1 equals to pi2. So once we have the h null and h1, then our next step is to create an expected frequency tables. And to calculate the expected frequency, what we do is that, for example, for female left-handed, what we do to calculate the expected frequency is that we take the column total, we take the 36 column total times by the row total. Row total is 120, and then we divide it by total sample size, which is 300. Same for female right hand. What we do is we take the column is your 264. So we take the 264, we times it by the row is 120. So 264 times 120 divided by the sample size total, which is 300. And that will give you the 105.6. Same for male left hand. To calculate the expected frequency, what we do is we take the column is 36 times the row is 180. So 36 times 180 divided by 300 will give you the 21.6. And then the last one is the male right hand. So column is 264 times 180, which is your row, and then divided by 300, your sample total. That will give you the 158.4. So that's how we solve for the expected frequency algebraically. Once we have the expected frequency, then I'll show you how to calculate the chi-square statistics. So the formula to calculate chi-square statistics is we're taking the sum of all the cell, for each cell what we're doing is we're taking the observed minus the expected, and then we're squaring that, and then we divide it by the expected frequency. So we do it for all cells. So in our example, we have 4 cells. So that's why we have 4 times here. So we have to do that calculation 4 times. Once we do the calculation 4 times, then we add them up. We're taking the sum of all these values. And that's our chi-square statistics. So for the first cell, what we have is the observed minus the expected square divided by the expected. So in the first cell, what we have is 12. 12 is the observed. Expected is 14.4, so that's why we have 12 minus 14.4 square divided by the 14.4, which is your expected. Second cell is your 108, that's your observed. Expected is 105.6, So what we do is we take the observed, so 108 minus the expected 105.6 square, and then we divide it by the expected 105.6, and that's your second cell. And then third cell, same idea. We have 24 as the observed, expected is 21.6. So 24 minus 21.6 square divided by 21.6. And the last one is 105. And the last one is your observed is 156. Expected is 158.4. So what we do is we take the 156, the observed, minus the expected square divided by the 158.4. Once we have these four cells calculated, then we add them up and we're going to get the 0.7576. So that's the algebraic method. So you can see that if you do it algebraically by paper manually, it's still doable right now because we only have 2 times 2. With 2 in the column, we have the 2 in the row. So it's still doable right now. But once we have more column and rows, if we have like 5 columns, 6 column, and then 5 rows, 6 rows, then it's hard to do it manually by paper. So that's why I'm going to show you how to do it in Excel.